Welcome to Code Jumper. This is about lesson 5, which is debugging. The objectives of this lesson are that students will understand the concept of a bug in computer programming, and they'll be able to identify and fix simple bugs in their own programs. The expected outcomes are that all students will be able to identify simple bugs in existing programs. Most students will be able to identify and fix simple bugs in existing programs, and some students will be able to identify and fix bugs in existing programs and explain their process for correcting the error in the program. Key vocabulary for this lesson are bug, which is an error or a problem within a computer program. The process of debugging, so debugging is another vocabulary word. The process of finding and fixing bugs or errors in computer programs, and software engineer, engineers who write computer programs for different types of software. In the unplugged activity, we are going to introduce the concept of programming bugs and learn how to identify the programming error in order to fix it. Make sure every program runs smoothly. For this unplugged activity, we'll need 5 sets of debugging cards. Each set is going to have 5 cards inside of it. Each set has some math problems, and there's going to be one of them that are incorrect. These problems should be easy for students at your level, so you could adjust them either up or down. We want them to be simpler than what they can do mathematically so that they can easily see the problem or the mistake in the cards. The debugging cards are located at the end of the lesson, and you can print them out in the format that works best for you and your students. Up on the screen is an example of 3 of the practice sets. So practice set 1 has 5, each of these mathematical equations will be written on a different card. So the first card will say 7 minus 4 equals 3, which you and I know is true. The next one is 6 plus 2 equals 8. The next one is 9 plus 2 equals 13. 5 minus 1 equals 4. 8 plus 2 equals 10. And students will go through that entire set in a small group and determine which one has a bug. Now, this is a really important skill. It's not so much finding the mathematical error that's the important skill. The important skill here is the way that students are working in their groups, the way they communicate when they see an error, the way they test their prediction or verify their theory about which one is wrong or which one is right, and most importantly, their listening skills. Are they listening to each other in the group? Does everyone have a chance to explain their thinking, agree, disagree? On something relatively simple like this, problems may not occur. But if we set the standard and the habits for this type of communication and this way of working in a group, when the problems do get harder, students can rely on this practice. This practice is very similar to how software engineers work together. After students have figured out which card has the bug in it, you can come back together as an entire group and discuss which ones have bugs, and most importantly, explaining why, and making sure everybody who is listening agrees with them. Next is the guided activity. In this guided activity, the objective is to listen to a sample program and identify a bug, then correct the bug in the program. The materials needed for this section are the debugging code card for Twinkle Twinkle with an error and the code card for Twinkle Twinkle without an error. So in this part of the guided activity, I am going to have students listen for an error. Up on the screen for you, I have the code written on the left-hand side of the screen for Twinkle Twinkle, and on the right-hand side of the screen, there's a hub connected to 4 play pods in thread 1. However, there's an error. And in this section, I have this up here for you to see that that there's an error, and I'm going to have you just listen to it first and see if you can identify the error. And this is what we'll do with students. We won't have students look at the app yet. We won't even have them look at CodeJumper when we're doing this demonstration. We want them to just use their ears and see if they can listen carefully and find the error. So here goes. So here on the screen, on the left-hand side, I have the app and I have my document camera just so you can see what I'm doing. I have the hub connected in thread 1 to 4 individual play pods, and I'm going to select the play button.
Twinkle, twinkle, star little.
Students might need to listen to it again. They need to attend to what is it that is different. What is different than the song that I know about Twinkle Twinkle? Then as you want to guide them towards solving this problem, you can introduce some of those vocabulary words and say, there's a bug, there's an error in our computer program, and we want to make it correct. And so we need to do the process of debugging and find the error. You might, at this point, sing with the class the song that you normally know, and then hit play again so that students can hear and listen carefully for the differences and identify where that might be happening. You could also introduce the concept and the vocabulary word of software engineer, that software engineers are people who often find bugs and errors in computer programs. In fact, they design them, they develop them, maintain them, test them, and evaluate different kinds of software. And this is part of their job. Students should be able to identify that that the third line or the third play pod has the wrong value for the parameter in the sound set. So it's right now saying star, and we want it to say little, and we want the fourth one to say star. As you go through and debug with them, this is a great opportunity either to demonstrate with your document camera how you are tracing the code to find the location of the pod that you're going to adjust. I'm going to switch back to the PowerPoint now. The next section of the guided activity is for students to identify an error in a program or a bug in a program that isn't maybe as obvious as something like Twinkle Twinkle that they probably already know. In this case, we want students to read through and identify what doesn't belong. All of these lines of code have something similar, and one of the lines does not belong. And so we want them to take the code card, the program with an error. It's in thread 1, nature, and it says play seagulls for 1 times speed, play crickets for 1 times speed, play thunder for 1 times speed, and play frogs for 1 times speed, end thread. By looking at this and identifying it, they might be able to figure it out from reading it. They might also need to get CodeJumper out and put it together and listen to it to see if they can identify what doesn't belong. Ultimately, they should figure out that thunder is not an animal, and so thunder doesn't belong, so they can substitute the pod that would normally play thunder. I think it's the third line of code, so the third play pod. They can substitute it with a different animal sound. Once everyone has figured this out, or the majority of your students, you'll want to practice again that discussion and the format for discussing, identifying the bug, and figuring out what it needs to be. The exploration portion of the debugging lesson, in this activity, students will create a program and then introduce a bug for another group to find and fix. Students will need the materials of the CodeJumper kit and their computer science journal. They'll create their program and then create a bug in it, and then they'll need to write down or touch type or somehow in their computer science journal put the code card for the other group to read and see if they can figure it out and see if they can figure out the bug. This is a fun way. This could actually be expanded quite a bit in your classroom and sometimes is a good warm-up activity for future lessons. Students really enjoy this activity. And that is it for debugging.